Okay, in the beginning of lesson 1.2, we're going to start talking about fractions. Now, fractions represent part of a whole amount that we have. And a fraction, we have one number that's written over another. This number right here would be called 7/8. The number 7 is in the top, and that's called the numerator. Okay, so numerator always means the number in the top. And then 8 would be the denominator because it's in the bottom. So the bottom number is called the denominator of when we're talking about fractions. Okay, so numerator and denominator. Now, simplest form, that's the topic of today's lesson when it comes to fractions. In algebra, we like fractions to be in simplest form. And that means we have a fraction that cannot be simplified any further. So a fraction that cannot be simplified any further. We've got it in its smallest numbers, so to speak. Now, if we like it in its simplest form, why are there other ways to write it? And again, it's because there's lots of ways to show parts of a whole. You might have lots of pieces to something or just a couple, but we can still show how certain values, fractions written with different numbers, can have an equivalent or the same value. So let's start this off. What if I have these two circles right here? If I said I had 4/8 or 1/2 of something, which one's bigger? Is there one that's bigger, or are they the same? So let's say this is pizza. Let's say my son ate 4/8 of a pizza or 1/2 of a pizza. Now, notice that this circle here is cut into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. Because I'm not a very good artist, they don't look like they're all the same size, but they're supposed to be. Now, notice that if I said this was pizza, this one's a pizza as well. But for some reason, the people at the pizza place only cut it into 2 pieces. So we have 1, 2, but notice that these 2 pizzas are the same size, and that's what it needs to be when it comes down to comparing fractions. The whole amount that we have, those 2 things do need to be the same sizes that we're comparing. I mean, it would mean something different if I ate half of a small size pizza versus half of an extra large size pizza, right? Those pieces of pizza are not the same, so it does no good comparing them. So my 2 pizzas, let's say they're both like larges. Okay. Now, if we said that he ate 4/8, this would mean that there was 8 total slices, and this is what, we ate 4. So let's shade the 4 pieces out. So 1, 2, 3, 4. So 4 out of 8 right here is showing that, it looks to me like half the pizza. Right? Is it? What if I say 1/2 though? Doesn't sound the same. Doesn't sound like it's as much. 1 is smaller than 4. 2 is smaller than 8. So is it the same? This just meant I had 2 total slices, but notice my slices are bigger because we have the same size total object. And that 1 is how many he ate. But if I shade that out, 1 out of that 2, we are covering the same amount. Okay, so what does that mean? 4/8 and 1/2. Okay, 4/8 and 1/2 are equal. They are the same. Okay, 4/8 is unsimplified. I could break it down, okay, and divide it and simplify it in all these different ways we'll talk about, but its true value is 1/2. It was still 4/8 here was half the pizza. Okay, so the simplest form of 4/8 is going to be 1/2. This is the true fraction number that we want. Okay, we can also do that with different types of fractions. Sometimes 1/2 is easier to see. Let's say I had some pie. Okay, I got 2 pies that are the exact same size, and this pie was cut into 6 pieces. And this pie over here was cut into 3 pieces. So we could say that my husband, he really likes pie, and he ate 4 out of the 6 pieces. So if I had these numbered, let's number 1, 2, 3, 4, 5, 6. And he does like pie. So if he ate 1, 2, 3, 4 pieces, he ate this much pie, which is not good for him. Okay, or then we got like a different kind of pie, and he still was hungry, still loves pie, so he ate 2 of the 3 here. Maybe it made him feel better just to cut it in 3 slices and say that he only ate 2 to make me think he ate less pie and was trying to be healthy. Now, did he eat the same amount? Did we cover the same? Here, 4, 6, okay, from here to here, and 2/3 was the exact same amount of pie. So 4, 6, give me back my pen. 4, 6 is the same thing as 2/3. They are the same amount, but 2/3 is the simplest form. Okay, simplest form. It's reduced. It just uses smaller numbers to show the same fraction. And again, for some reason in algebra, that's what we seem to like. We want to write the fraction with the smallest numbers possible. So in the next section, we're going to be given a fraction and we have to simplify it. Now, if you were in middle school or elementary school, you would be expected to do this with mental math or like long way. But because we are in high school and you can always use a calculator after this, you're going to be allowed to use your calculator. And later on, we're going to do an activity where hopefully you can tell me if a fraction is in simplified form or if it was not simplified. And then we're going to get on to mixed numbers and improper numbers. And I just would like you to be able to recognize which form it's in. So on numbers 1 through 9, this is going to be a lot of calculator work again. And we might show what's going on here. But I have 8 over 20. Woo, got crazy. And we need to simplify it. We need to write it in its smallest form. The nice thing is that calculators will do this for you. So in class, we're really going to talk about how to use your calculator. If you have a Casio, there's going to be an actual like fraction button. It shows like a box, then a fraction bar, and then a box underneath. And you would put 8 in the top box, push your down arrow, put 20 in the bottom box, and then hit equals. If you're using a TI, you're going to type the top number 8 and then the ABC button, which will put like a little backwards L, which represents a fraction bar, and then hit 20 and then hit equals, and out it's going to pop 2/5, okay, which is the same thing as 2 over 5. Okay, those are the same thing. So 8/20 and 2/5, these two values are equal, but 2/5 is the smallest way of showing it. Okay, next we have negative 6 over 18. So we have negative 6 over 18 out of 18 pieces. What does this simplify? So again, you'd put negative 6 in the numerator. Whenever there's a negative number, we put it in the numerator. Otherwise, our calculator might tell us error, syntax error. And we get negative 1/3. So this is saying that negative 6 out of 18 pieces is the same as negative 1 out of 3 pieces. But negative 1/3 is the smallest way to write it. Okay, what about 21 over 27? This would mean 21 out of 27 total pieces. If we type that in, 21 over 27, out would get 7 over 9. 7 over 9 is the smallest way to write that. It's the same as 7 out of 9 pieces. Number 4, we have negative 24 out of 40 pieces. What's the smallest way to represent that? It would be so you type in negative 24 over 40, and we get negative 3/5. That is its simplest form. Number 5, we have negative 12 over 42. So if we type that in, hit equals, our calculator will tell us that this is the same as negative 2 out of 7. Number 6, 36 out of 45. This could mean that there was 45 total pieces to something, and you got 36. It would also be the same as if there was 4 out of 5 total pieces of the same size of object, and you got 4 pieces. Number 7, 16 over 56. We had I don't know why I'd want to cut something into 56 pieces, but if I did, it'd be the same as 2/7. What about this one? 18 over 3. Notice our top number, our numerator, is a lot bigger than our denominator. Sometimes we don't get a fraction at all once we simplify this. This is 18 over 3, which is 18 divided by 3, which is equal to 6. And last but not least, number 9, we have negative 8 over 28 total. So this simplifies to negative 2 over 7. Okay, so on today's lesson, we will be practicing simplifying fractions. And it's just a matter of understanding that even though they're different values, like 8 over 20, it's the same thing as 2 out of 5 if we were comparing the same size object. It's just how many total pieces we cut it into might have been bigger or smaller, but we would have gotten a proportionate amount. Okay, that's it.